Hello, this is your special education virtual content specialist here with the 8th grade lesson for May 10th. This lesson and all other lessons can be found on TeachHub. All these lessons contain the title, the focus question, the learning objective, including the standards and objectives for each lesson. Additionally, we provide guidance for using this resource, including instructional and technology guidance, implementation guidance for the lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging with students with disabilities and multilingual learners. 8th graders are working on Unit 8, the Pythagorean Theorem and Irrational Numbers. Day 10, Reasoning about Square Roots. Part B, How can a number have more than one square root? The introduction asks students which of the numbers listed to the left would fall between 8 and 10 on a number line. Explain your thinking. To support students with disabilities, you can make a number line with 8, 9, and 10 and have them go through each number with their peer partners. That way they can discuss the values of each of the numbers. Students should know that 9 falls at 9, so that will fall on the number line. 60 is greater than 10, so it will not fall on the number line. 70 is also greater than 10. Square root of 9 is equal to 3, so it will not fall on the line. Square root of 60 will not fall on the line because it is less than 8. And lastly, square root of 70 falls between the square root of 64 and the square root of 81. So it will fall somewhere between 8 and 9 on the number line. For the Explorer, the purpose of this activity is for students to use rational approximations of irrational numbers to place both rational and irrational numbers on a number line and to reinforce the definition of a square root as the solution to the equation of the form x squared equals a. This is also the first time that students have thought about negative square root. To support students with disabilities, especially those with conceptual processing issues, you can use in-person manipulatives or virtual manipulatives. So use a kinesthetic representation of the number line on a clothesline so students can place and adjust numbers on a folded paper cardstock or on a virtual manipulative website in a hands-on manner. Additionally, as seen here, I provided a sentence starter for students so they can focus on answering the question rather than focus on the sentence structure of their answer. Students will place x equals square root of 3 right there. So x equals square root of 3, y equals square root of 16, and z equals square root of 30. And those numbers were placed there because students should know that the square root of 3 would fall between the square root of 1 and the square root of 2. The square root of 16 is exactly 4, and the square root of 30 would fall between 5 and 6. For this portion of the Explorer, a group of students was given the following equation: x squared equals 49. John said that in this equation, x equals 7. Maria says she found another answer that also works. Could Maria be correct? Is there another answer that fulfills the equation? Explain your thinking. Students have not explored this yet, but Maria is correct because x can also equal negative 7. Students may be confused, but you're going to move on to the following slide to explain to them why x equals negative 7 is also acceptable for this equation. So you're going to explain to students that equations of the type x squared equals a have two solutions when a is a positive number. Those solutions include a positive and a negative value that can be represented as square root of a and negative square root of a. For example, The equation x squared equals 20 has two solutions, square root of 20 and negative square root of 20. For this portion of the Explore, you can divide each of the prompts into an I do, we do, you do. Additionally, I switched the order so that students doing the we do can feel a little more success, since m squared equals 121 is a perfect square root. For the I do, I'm going to show students that when I do the square root on both sides, z is equal to positive and negative square root of 88. For the we do, students should know that m is equal to positive and a negative 11. And for the you do, students are going to say w is equal to positive and negative square root of 32. For this portion of the Explore, now students are going to place negative square root of 2 on a number line, and they should be able to realize that it goes between -1 and -2 on the number line. Because they should remember from a prior lesson that square root of 2 is between +1 and 2, so negative square root of 2 should be between -2 and -1 on the number line. Now students are asked to find both solutions to the equation x squared equals 40 and place them on the number line. The square root of 40 would fall between 6 and 7 on the number line. X equals square root of 40. So that means conversely, negative square root of 40 would fall between -7 and -6 on the number line. Only one plot would be available on this particular number line. For the summary, you can support students with disabilities by giving them a sentence starter, and then they can complete the cool down. There is a video to support students who struggled with the lesson.
For additional practice, students can complete IXL F.17, positive and negative square roots, and if not completed in part 1, the open up practice problems. Additionally, this lesson was created using illustrative mathematics and open up resources, so feel free to utilize these materials to support your students' remote learning. If you have any questions, reach out to a virtual content specialist. Thank you.